All right, let's dive into one of the most, honestly, mind-bending concepts in all of physics: antimatter. Think of it as the universe is perfect, but also its most destructive opposite twin.
So what if you had a perfect opposite? I mean, a literal twin, someone identical to you in every single way? Well, almost every way. There's just one tiny detail that changes, well, everything.
Because this isn't just an opposite. They're your anti-you. And here's the crazy part. If you two were to ever meet, if you even just touched hands, you would both just annihilate, gone, vanishing in a massive burst of pure energy. But here's the real twist. This isn't some sci-fi plot. This mirror substance, antimatter, it's totally real. And even crazier, tiny, tiny amounts of it are being created inside your body. Like right now, as you're listening to this.
Yeah, believe it or not, that banana you might have had for breakfast, well, it contains this naturally radioactive element, potassium-40. And as that potassium decays inside you, it's totally harmless, by the way, it actually emits particles of antimatter. Now, they're gone in an instant, but for a split second, they're there.
Okay, so what is this stuff, really? To get it, we have to look at the fundamental difference between our reality and its mirror image.
The core idea is actually pretty simple. For every single fundamental particle that makes up our universe, think electrons, protons, the whole gang, there's an antiparticle, a twin. And this twin has the exact same mass, but the complete opposite electric charge. That's it. That's the key.
Let's make this super clear with the most famous example, okay? The electron. We all know it has a negative charge, right? Well, its antimatter twin is called a positron. It's identical in every way. Same mass, but it has a positive charge. It's like they have the same weight, but a totally opposite personality.
What's amazing is that this whole thing started out as just math, pure theory. Back in 1928, a physicist named Paul Dirac was working on an equation, and it just spat out this weird prediction. It described a particle exactly like an electron, but with a positive charge. And then, only 4 years later, they found it. They actually discovered it in the real world. And today, we create antimatter pretty routinely in places like CERN.
So, we've talked around it, but let's get right to it. What actually happens when these opposites finally meet, when a particle of matter and a particle of antimatter come face to face?
Well, the rules for this encounter were written by the most famous equation in all of history. Yeah, you know the one, E = mc squared. Einstein's masterpiece is basically the ultimate recipe. It tells us that mass itself is just an incredibly concentrated form of energy, just waiting to be unleashed.
See, when matter meets antimatter, they don't just bump into each other. They annihilate, 100%. All of their combined mass is converted instantly into a flash of pure energy. We're talking high-energy gamma rays. There is no more efficient, more powerful energy release known to science. Nothing even comes close.
Okay, an interaction that powerful, it sounds like something straight out of a doomsday movie, right? The ultimate weapon. But what if we could control it? What if we could actually harness that unbelievable burst of energy and use it for something good?
Well, the really surprising thing is, we already do. Right now, in hospitals all over the world, that exact same process, the one that could theoretically power a starship, is being used to save lives. It lets us see inside the human body with incredible detail.
It's called a PET scan. That stands for positron emission tomography. Here's how it works. First, doctors give a patient a special tracer that emits positrons. Remember, those are the antimatter version of electrons. Now, this tracer collects in areas that use a lot of energy, like, unfortunately, tumors. So as those positrons from the tracer bump into the regular electrons in the body, poof, they annihilate. The PET scanner detects those tiny energy bursts, and by mapping them all out, it creates this incredibly detailed image showing exactly where the disease is. It's literally medicine powered by antimatter.
And that's just what we're doing today. Medical imaging is just the beginning. Imagine rockets that could get us to other stars, not in centuries, but in a single human lifetime. Or brand new experiments that could unlock the deepest secrets of the universe. These are the kinds of frontiers that antimatter research is starting to open up.
But for all we know, and for all its potential, antimatter also leaves us with one of the biggest, most profound mysteries in all of science. It's like a cosmic disappearing act on a scale that's hard to even imagine.
So here's the puzzle.
According to our best theories, our best understanding of physics, the Big Bang should have created matter and antimatter in perfectly equal amounts, a perfect balance.
Okay, so if that's true, think about it. If there were equal amounts, everything should have immediately annihilated everything else. The entire universe would have just been one big flash of light, leaving nothing, an empty void of energy. But, I mean, look around. That's obviously not what happened. So the question that keeps physicists up at night is, where did all the antimatter go?
Because when we look out into space, all we see is matter. Galaxies, stars, planets, us. It's all made of matter. The antimatter? It's basically gone, vanished. For some reason, in that cosmic battle, matter won.
And figuring out why, solving this mystery, why the universe seems to be biased, why it picked matter over its perfect twin, that is one of the absolute biggest goals in physics today. Because the answer, whatever it is, could literally rewrite our entire understanding of the cosmos.
Because when you really get down to it, this isn't just a question about some exotic particle. This cosmic imbalance, it's the only reason we're here. It's the reason there are stars in the sky, a planet to stand on, and people like us to even ask the question in the first place. Why is there something instead of nothing at all?